Every monsoon, the same scenes return. Busy roads disappear beneath murky water. Cars stall, buses struggle forward. Pedestrians wade through flooded intersections. And across Kolkata, one question echoes again and again. Why does waterlogging continue despite pumps, drains, canals, and decades of infrastructure investment? As another monsoon approaches, city officials are reviewing preparedness, inspecting vulnerable locations, and directing engineering teams to minimize flooding. But can waterlogging truly be eliminated? Or is the challenge far more complex than it appears? Today we explore the engineering realities beneath Kolkata's streets. To understand waterlogging, we must first understand Kolkata itself. Unlike many cities built on elevated terrain, Kolkata developed on the lower reaches of the Ganges Delta. Much of the city lies only a few meters above sea level. Historically, large wetlands, marshes, canals, and natural depressions stored excess monsoon water. These natural systems acted like giant sponges. Over time, urban growth transformed many of these landscapes. Roads, buildings, and paved surfaces replaced areas that once absorbed rainfall. As a result, rainwater today reaches drainage systems far more quickly than it did decades ago. And when rainfall arrives faster than water can leave the city, waterlogging begins. Most people see only the water on the road. What they don't see is the vast drainage network operating beneath the city. When rain falls, water enters roadside drains. These drains connect to larger underground sewers and canals. The canals then transport water toward pumping stations and discharge points. In many locations, gravity alone cannot move water efficiently. Pumping stations play a critical role. They lift stormwater and help move it toward rivers, canals, and outfall systems. During moderate rainfall, this network generally performs as intended, but every drainage system has a design capacity. When rainfall intensity exceeds that capacity, water begins accumulating faster than it can be removed. The result becomes visible on the streets. Waterlogging is rarely caused by a single factor. Instead, it is usually the result of multiple challenges occurring simultaneously. The first challenge is rainfall intensity. A drainage system designed decades ago may struggle when extreme rainfall occurs within a short period. The second challenge is sedimentation. Silt, debris, and waste gradually reduce the carrying capacity of drains and canals. Even small reductions in flow area can significantly affect performance during heavy storms. Third is urbanization. As more land becomes paved, less rainfall infiltrates into the ground. More runoff enters the drainage system almost immediately. Another important factor is tidal influence. Parts of Kolkata depend on outfalls, whose performance can be affected by river water levels and tidal conditions. When downstream water levels rise, drainage efficiency decreases. Then there is the issue of maintenance. Drainage systems require continuous cleaning, inspection, repair, and upgrading. Even well-designed infrastructure can underperform if maintenance is neglected. And finally, climate variability is increasing the likelihood of intense, short-duration rainfall events. These events place enormous pressure on existing infrastructure. The challenge is not simply engineering. It is engineering operating within evolving environmental conditions. With the monsoon approaching, what practical measures can reduce waterlogging risks immediately? The first priority is desilting. Removing accumulated sediment from drains and canals restores hydraulic capacity. The second priority is ensuring pumping stations are fully operational. Mechanical failures during extreme rainfall can quickly worsen flooding. Backup power systems are equally important. Storms often coincide with electrical disruptions. Emergency mobile pumps can be positioned at known hotspots. Critical drainage corridors should be inspected and cleared before major rainfall events occur. Real-time monitoring systems can help operators respond more rapidly. Forecast-based preparedness allows engineering teams to act before flooding develops. None of these measures can guarantee a flood-free city, but together they can significantly reduce both water depth and waterlogging duration. The larger question is how Kolkata can become more resilient over the coming decades. One important solution is modern drainage modeling. Digital hydraulic models can simulate how water moves through the city under different rainfall scenarios. These tools help identify bottlenecks before flooding occurs. Canal rehabilitation is equally important. Many urban canals have lost carrying capacity due to sedimentation and encroachment. Restoring these waterways improves overall drainage efficiency. Protecting remaining wetlands is another critical strategy. Natural storage areas reduce pressure on engineered systems. Future developments can also incorporate permeable surfaces, retention basins, and stormwater storage facilities. Pumping infrastructure will require modernization as rainfall patterns evolve. And perhaps most importantly, forecasting systems must become fully integrated with drainage operations. The future of urban flood management will depend not only on concrete and pumps, but also on data, prediction, and real-time decision-making. Cities around the world face similar challenges. Singapore combines drainage infrastructure with advanced forecasting and water management. Rotterdam designs urban spaces that temporarily store excess water during storms. Tokyo has invested in massive underground flood control facilities capable of handling extreme events. Each city has developed solutions suited to its own geography. Kolkata's future solutions must be equally tailored to local realities. As another monsoon approaches, expectations will once again focus on flooded streets and waterlogged intersections. But behind every storm lies a complex engineering challenge. The goal may not be to eliminate waterlogging completely. The goal is to reduce its frequency, depth, duration, and impact on people's lives. Because cities, like rivers, must work with nature as much as they work against it. And perhaps the future of Kolkata's flood resilience will be shaped not by a single project or a single season, but by decades of thoughtful engineering, maintenance, planning, and adaptation. Engineering Earth Balance, Flowline Chronicles.